Hey, what's going on, guys? In this video we are going to see how to create a circuit, op amplifier circuit, that can give V output voltage that is equal to 3V2 minus 5V1. Okay, so first we want 3V2. In order to bring this one, I'm going to create a circuit that the input voltage is connected to the inverting terminal. Now let's go ahead and do that. First we had to have V2, so I'm connecting V2 right here, and also we are going to have the resistance here, and also we have the operational amplifier, and this is negative, this is positive, this is inverting, this is non-inverting. Non-inverting is connected to the ground, and inverting, I have a feedback resistance right here, and that's it. So this is my first equation, and let's call this one VO2, and this is our feedback resistance RF2, and let's call this one R2. Okay, so when we have inverting op amplifier, the output voltage equation is always like this: VO2 is equal to negative feedback resistance, that is RF2, divided by the input resistance, that is R2, times the voltage input, that is V2. So this is always the case when we have inverting op amplifier. Inverting is the input voltage. When the input voltage is connected to the negative terminal, negative is inverting. When we have that situation, the output voltage is going to be like this. Okay, so we have VO2. Now first thing is we need 3V2, but here it's positive, but however we are going to get the negative answer. Later we can turn it into positive by connecting another inverting op amplifier. So let's derive negative 3V2 for now, then we can change it. Now to derive negative 3V2, we can put many different values. Here I'm going to take 30 kilo ohm for RF2, then for R2 I can take 10 kilo ohm. In that way we will have 3, right? So 3V2. So finally we will get VO2 is equal to 3V2. Now let's connect another circuit. So here we have VO2, and I want the final one 5V1, right? So we have to connect V1. Now this is in terms of VO2, but when we are going to connect this one with inverting terminal. Inverting terminal is negative, this is positive. Positive, I connect this one to the ground, and that is 0, ground is 0, so we don't have to worry about this thing. But we also want V1, because this one is in terms of V2, so we also want V1. So to get V1, what we can do is we can create another thing right here like this, and we can create another input voltage that is equal to V1, and let's call this one R1. And also we need a feedback resistance. Let's put this one right here, and that's gonna go like this. Let's call the last one VO, that's the one we are trying to find. So this one is VO, and here RF1. So we are going to create this VO equation that will give us 3V2 minus 5V1. We already create VO2, that is already created VO2, that is equal to negative 3V2. Now we have to change this sign. Since this is connected to the inverting terminal, we are going to get the opposite sign, so we don't have to worry about this one, because this sign is going to flip around when we create the equation. Now let's see what's going to happen here. Since we have two input voltages, we know that when we have inverting op amplifier, this is the equation, right? This is the equation always. But when we have two, here you can see, here we have VO2, one input voltage, and also we have V1, another input voltage. So we are going to have this equation is going to be with two input voltages. So we are going to have V output that's equal to negative, and then this is RF1, feedback resistance, divided by this resistance, that is R2, times the corresponding voltage, that is VO2, plus we have another input voltage, that is V1. So for that one, feedback resistance is still same, that's RF1, divided by the resistance, that is R1, times the input voltage, that is V1. Okay, so this is going to be the equation for this inverting op amplifier. Now here we know that RF1, okay, we don't know, like we want this one to be 1 because VO2, this is our VO2 value, this is negative 3V2. For the first value we want 3V2. In order to get 3V2 we have to make this ratio 1. In that way we will have negative 3V2 right here, then negative negative, that will turn this one into positive. So let's go ahead and see how we can do that. So this is going to be minus, and let's put the ratio 50-50. So 50 kilo ohm divided by 50 kilo ohm times VO2, that is negative 3V2. And if this is 50, it's easy to create 5, because if the RF1, because we already put RF1 50, so we have to keep the same value. If RF1 is 50, then to bring 5 to the answer, because we want this one to be 5V1, so we can put 10 kilo ohm in the denominator. So 10 kilo ohm, in that way we will get 5 right here, right? And this is multiplied by V1, and finally we will derive VO, that is equal to 3V1, actually 3V2 minus 5V1. And that's how we do this kind of things. I hope this helps. Thanks for watching.